Right, now tell me what do you mean by double OP concepts? What do you know about object-oriented programming? Or what do you know about the concepts of double OP or object-oriented programming in Java?
Abstraction, encapsulation.
Abstraction,
Methods.
encapsulation, yes. Polymorphism, yes. Like when you ask someone asks what are the double OP concepts, yes. Those are the things coming to your mind. Abstraction, encapsulation, inheritance, and polymorphism. Like right. Then, as we discussed on the very first day, Java supports for object-oriented programming concepts. Right. Therefore, that means if it is a double OP language means the programming language uses objects in programming. Therefore, the language uses objects as a primary source to implement. Right. Then, in object-oriented programming, right now it tries to implement real-world entities like inheritance and hiding the data or communicating with multiple forms, like in programming as well. Right now, then there are main concepts as you just said: abstraction, data abstraction, encapsulation, inheritance, and polymorphism. Likewise. Right. Therefore, in order to talk about object-oriented programming concepts, there are some prerequisites right now. Those are like access modifiers. Then, if you can remember last time we discussed about the access modifiers. Right, then tell me what are the access modifiers? Okay, what is an access modifiers given for class? What are the access modifiers that we can use with class? What are the access modifiers can be used in a class?
Private public protected.
Okay, can we have private classes? I think last week we discussed about what are the access modifiers can be used in a class. When you are declaring a class, what are the modifiers you can use?
Public, private.
Private class?
Only public.
And remember? Okay, tell me the access modifiers. What are the access modifiers? We mainly discuss about 3, 4 types. Access modifiers, what are those? 4 main types we discuss. Yes?
Public, private, default.
Yes. One more, protector. Public, private, default, protector. And then private means only within the class. Default means default access means what? Last week we discussed, right? Default means within the package level. And then protected means package level plus through inheritance, subclasses. Public means any class good access, right? Therefore, right now, I think it's better you refer to the previous recording then, if you can't remember right now. Therefore, one requirement to talk about the object-oriented programming in Java is access modifiers. Yes, access modifiers define the access type for a method or for a variable. Like then we discussed about 4 types. All right, public, which provides access to, if it is for an attribute, if you use, that will provide access for all classes in your application. If it is protected, it will provide the access within the package plus like subclasses not in the package or outside the package. Therefore, within the package level plus through inheritance, even outside the package. Then private means within the class only. Default means package only, within the package only. Right. Then we discuss about the access modifiers, and thereafter we discuss about how to declare methods, what are the return types, and what are the parameters. Likewise, we discuss. And then we discuss about like how to define the parameters and how to pass the arguments. That also we discuss. Right. Now, by knowing those, right now we can talk about the object-oriented programming concepts. Right now, in Java, there are four main areas. Right now, the four main areas are, right now, initially you need to talk about what is a class, what is an object, and what are the methods and what are the parameters, what are the arguments, and thereafter, four main parts which are abstraction, encapsulation, inheritance, and polymorphism. Right now, we have mainly we can say if someone asks, okay, what are the OOP concepts? Then you should say, right, yes, abstraction, encapsulation, inheritance, polymorphism, like that. Then before we go into that, we discussed that a class. We know what is a Java class. Java class, we call it as a template or a blueprint. Based on the Java class, you could declare objects, you could create objects. Therefore, how objects should behave is declared by a Java class. And inside a class, you can have methods and the variables. You could have methods and the variables. Then using a class, you could create multiple objects. Right. Therefore, which has the same behavior, right, without duplicating the code again and again. Therefore, you create a class and then you could use the same behavior by creating multiple objects from the class. Right. Therefore, class, we can call it as a blueprint or a template, which used to create objects. Then we use, when you're creating a class also, we use the access modifiers. That's what I asked at the beginning. Then we discussed that we can have public access or default access. A class can be declared with public or default access. If there is no keywords used in front of the class name, then that means default access. That means you are providing access only within the package. Therefore, outside package will not be able to access it. Therefore, if you want to allow to access to any Java class, you have to make it as a public class. And then after the class keyword, you need to follow the class keyword by the class name. Then we said that you have to start with a capital letter. Right. And thereafter, we can have the body statements. Inside the body of the class, we can have variables and methods. Then we could create objects from the classes. Therefore, let's quickly create, let me create a new project quickly. The Java application, next. Project name, even. Right, finish. Right. Okay, right now, let's say now this is the class with the main method and I'm going to create another class. Right now, new Java class for student. Right now, there I'm going to declare a variable called name and a method called say hi. Say hello. Right. Now we have a class created, which is a public class actually. That means any class could access now. But anyway, this is not required because we are talking about the same package, right? Then this is the class with the main method where I'm going to create an object of the student class. Student s equals new student. Right. Right now here we can call s dot say hello and right s dot say hello. Right. Now this is what right now we can do, and we can assign a value to the name variable. Right now we're gonna print the name of the name variable value. Right now if you run this, you will see now here we'll be able to access the student class name variable here. That's why here we have assigned a value for that, and then we can call the say hello method. Right now you know that when you're creating an object from a class, right, every object has a state, every object has an identity, every object has a state, and every object has behaviors. State means whatever the variables declared inside the class. Right, the variables declared inside the class we call as states, and here we have behaviors. The student object can say hello. That means the methods declared inside the class. State means variables declared in the class. Behavior means the methods declared in the class. Right. Then every object has a name, identity, and know the states, the variables from the class, and it can do some task, which is the behavior. That means the methods declared in the class. Right. Okay. Then when you're creating a object, we call class name, right, and variable name equals, use the new keyword to create a new instance, and we initialize it by calling the constructor. And then since we have already discussed about the constructor here, if you do not declare the constructor, which is not declared here, since the constructor is not declared here, the Java compiler will create the default constructor. Now this is what called here. Right here it's called the constructor. Right now if you declare the constructor, yes, you can declare the constructor as well. Then you can declare the constructor. Right now you can declare the constructor with no parameters. Right now here, if you want, you can tell that student object create. Right now here you can have a method called student object create. Right now when you run this, right now here when you call the constructor, here this part will display the student object created. Right now that is the constructor. Right now when you are creating the constructor also, you can have the parameters as well. That also we discussed last time. Right now here even you can have the parameters declared in the constructor. Right now tell me and how can I assign the name of the parameter variable value here to the instance variable? Well, how can I assign?
This dot name.
Yes, we use this keyword in order to access the instance variable. Right now, otherwise, what happens is name equals name. If you mention, right now you can see here. If you select this, now the name variable, the parameter variable here, these two get highlighted. And if you select this name, nothing will get highlighted because this is the instance variable. Right, if you use this keyword now, when you select this name, you can see instance variable highlighted. If you select name, then here it will highlight the local variable name. Right, now what happens here is whatever the value of this variable gets assigned to the instance variable. The student object let's say student name, student. We can have the name created. Now we can say student name created. Right. Okay. Then here when you call the constructor, that happens, and then we don't need it. And here now we can see here, since the constructor is declared with the parameter, then you need to pass the argument. Right now you have to pass the arguments. That means you have to pass a string value, because this method declared with the string variable. Therefore here we have to pass a string value. Right now let's say a student name created inside the say hello method. Let's say we'll say the name says hello. Right now it will print name says hello. Right now what happens is, now when you run this file, right now at the creation of the student S object, it will display the student, whatever the name you have passed. Jane Doe has created student, Jane Doe created, it will display, and then say hello method will display Jane Doe says hello. Right now this is how it works. Right now this is what we have already done up to now, because we have already discussed this. Right now here we have an issue now. The issue is the one who has access to the student. The one who has access to the student can manipulate the variable values. Right now here you could say student name is equals to not Jane, like you can have, and right now I can just set the variable name as and. Right now if I print, now what will happen? Now previously it was name was Jane Doe, but now here I have changed it. Therefore, any class who has the access to the class now can change their instance variables. Right now, if you have given the public access or a default access, then right can change their values of the instance variables. Right now, if you don't want outsiders to use with the instance variable values, right now tell me, how can I protect it? How can I block it? How can I restrict outsiders to change the values of the instance variables? How can I do it?
Declare the variables as final.
If you declare the variable as a final, then no one will be able to change anything, right? Final variables will not be able to change. Therefore, even you will not be able to change the value. Therefore, the final variables can be used when you have declared a value and when you don't want to assign it. But right now here, I need to initialize it. Afterwards, I don't want to let it change I want to change the variable, but not to the outsiders. That means within the class I should be able to change, but not to the outsiders. How can I restrict the access of my variable name from the outsiders? How can I do it? By making it as
Private access.
exactly. Right now, by making it as a private access, I can say right now I'm gonna make this is default access now. Therefore, within the package, they can access. Since both classes are in the same package, now you could do it. By any chance, if it is a different, let me show you. If I create another package, code, and if I put my right, refactor main method, the class with the main method into a different package now. You can see when I try to access the name variable, now I can't. Why? In the student class, the say hello method and the instance variable declared as default access. Therefore, outsiders are not able to access now. They are not allowed to access because default access. If I want to provide outsiders to access, then I have to declare it as public. Right now, here you can see the here this error will go now, because the hello method can be accessed, but the name variable cannot be accessed. Actually, I don't want I don't want to allow the access, therefore I'm going to make it as even private. Now, if you have no access modifier used, if the both classes are in the same package can access, no. Therefore, I'm going to make it as a private. Now, even though this is in the same, this is inside the same package. Right now, even though that the both classes are in the same package, cannot access the right now here. Now cannot access this line is not necessary. Now cannot access the name variable because of the private field. Like if we have no private field declared here, right now here from the main method can access the name variable because default access within the package level access is there. Therefore, in order to avoid that, I'm going to make it as private name. Right. Therefore, now outsiders will not be able to access it. I have restricted the access only within the class. Right. But I want to allow outsiders to retrieve the value of the variable name. Now think. Now I want outsiders to see the name of the whatever the value of the name variable. I want outsiders to see it, but not to change it. How can I achieve it?
Making it protected.
No, Bhude. Now, previously it was default. Therefore, what has happened? Right now, since default means package level access, no. Therefore, whoever the classes inside the same package using the object name dot operator could access the attribute name s dot name. In order to avoid this, I don't want outsiders to change the value because they can read the value, they can change the value. Because they can print the value of the variable name and they can change the value of the variable name as well. Therefore, in order to stop it, I have make it as a private field. Right now, the attribute is private. Therefore, outsiders will not be able to access using the object name dot whatever the attribute name. Object name dot field name is not accessible now. Therefore, now since the name is a string private variable here, you will be not be able to access it. But now again, I assume, okay, I want to outsiders to read the value of the variable. Read the value of the variable. I want outsiders to see the name. But how can I do it? How can I do it? Why I will give you it by making a method, you could do it.
Make the variable private and make a method get
Yes,
and set variable.
yes, you can have any method. Yes, the name, right? You can declare any method, and then if you want, you can have a method called. Let's say now I want to return the value. Therefore, string value has to be returned. Then I can return public string, and let's say I can have any name, whatever the wish. But like in order to have a common name, I can say get name. Right now, this will return the name variable. Therefore, here I'm going to say return name. Right now, if someone wants to access the name variable, now I have declared a method. Like I have made the instance variable as private by blocking all the access to the name variable using the dot operator. And thereafter, I feel like it's better to allow outsiders to read the values of the name variable. Therefore, I'm going to declare a method called getName. Therefore, here if I want to read the value of this, I have to call whatever the object name s dot the get name. Right now, s dot get name will return the name of the whatever the variable name value. Right. It just print the J and do, because now I have declared a method called get name. And this is because I wanted to. This is because I wanted to allow the outsiders. And again, after certain time, I thought of like, okay, I want to allow outsiders to change the value as well. I want to allow outsiders to change the value as well. Therefore, I'm going to declare a method called set name. Therefore, there has no return type. Void set name, and here you need to have the new name for the variable as well. Right, a new name. Then you can say this dot name equals name. Right now, if someone wants to change it, they have to go through the set method, and if they want to retrieve it, you have to go through the get method. Right, therefore, even if I require only, I have to declare this. Otherwise, if I feel like I don't need it, then you don't need to declare the get method or the set. Right. Now, declaring getters and setters is called as creating accessor methods. Right now, this is what you call as encapsulation. Encapsulation. Right. You protect all the instance variables of a class by making as private and allowing outsiders to use it through public methods. Therefore, you have the option to select whether you want to create a public get method or public set method likewise. Therefore, this is what you call as accessors, right? Getters and setters. Right. Now, here we have discussed now two things. What are the two things? Abstraction and encapsulation. Right now, abstraction. What is abstraction? Abstraction means simply data hiding. Right? Data hiding. Abstraction means data hiding. That means in the using the data abstraction, right? You display only essential values to the users, right? Then, right, all the values are not disclosed to the user. Only display only the required fields only. That is what we call as abstraction. Right, now for an example, for a student, you display only the name, not the marks. Right, that means data abstraction means, right, now data hiding. Right, now, okay, now for an example, if you consider data abstraction, that means like, right, okay, now you know that using your mobile phone, whenever you want to make a call, when you dial, when you click call, right, the phone rings. Then the other side, the recipient phones also get rings. And then once they answer the call, the line connected. But you don't know how it is working, right? You don't know how here when you dial the number, what happens to that, and how to transmit that one through the networks, and even like from the cell tower to here, how it right, how they transmit, and then how the encode happens, how the decode happens. We have no clue how it happens, but we only see whenever we want to dial, we just press a button, and then that makes a call, and then the other party phone rings, and then once they answer, we can have the conversation. Right? We only know that we have to just dial the number in order to make a call, but we don't know what's happening, the mechanism behind that. Now that is what you call as abstraction. Right. That means right now we only see right now how to make a call, but we actually don't know what is happening, what is the mechanism, what is the procedure of making a call or connecting a call with the other party. Right. Therefore, that is what you call as the abstraction. Like class is an example for an abstraction. Right now, class declare what are the methods available, and all the code resides inside the methods. And then you see outsiders see the methods name, but you don't know. Outsiders does not know what is inside the method. Right now, outsiders can see. Right now, there's a method, and then outsiders does not know what is inside. How you have declared it, or you can call about abstract methods. Then abstract methods, then you have the method declaration, but not the implementation. Then the abstract methods are declared or implemented in the subclasses. Like now, for an example, again you can say data abstraction. You can have using abstract methods, right? Now that is about data, right? Abstraction. What is abstraction? Abstraction in simple words, you can say hiding internal details and showing functionality is known as abstraction. Right then, I use the making a call as an example. Actually, you only know when you dial the number. When you dial the number, the call connects, but you don't know the internal process. Likewise, data abstraction means hiding the data, hiding internal data and showing only the functionality. Right now, for an example, here outsiders, you say only, okay, this method can calculate, but you don't say how the calculation happens, but it does calculation. Likewise, abstraction. And then we have encapsulation. We have encapsulation. Right now, encapsulation means binding all the codes and the data together into a single unit, which you call as encapsulation, like in medical drugs. Outsiders see only the capsule. You know that inside that there are medical particles or whatever medicine is there, but you don't know exactly what is it. Sometimes you will not be able to see what's inside. You only know that there's something inside the capsule. Therefore, the same mechanism, we call it as encapsulation. Right. Therefore, how do you achieve the encapsulation? Encapsulation is achieved by making all the attributes, as private, and by declaring, make all the attributes as private and declare public accessor methods, getters and setters, accessors. Right now you can call accessor methods, public accessor methods. That means you declare only the getters and setters as required. Now this is how we call as encapsulation. Encapsulation means you make all the variables into instance variables into a private, and then you make only accessor methods or the functions, variables, public methods in order to access those. Right now, that is what you call as encapsulation. Encapsulation, right? Okay, in NetBeans, like if you are using this NetBeans right now, let's say I wanted to do this task, right? You don't have to worry at all. Right now, if you wanted to do this, declare the class student and declare variable name and declaring the constructor like this and then declaring the getters and setters. You don't have to worry at all. Right? How you do it using NetBeans. Right now, let's say we have integer. Okay. Let's make it as an item class. Okay, let me delete the student class. Right now, I'm going to make a class as an item. Right now, then the item class has item ID, integer, item ID, and string item name, and float price, and integer quantity. Right, now these are the variables I need for the in order to explain the item class. Right, therefore once you declare the variables, it's very easy now. You just see I have typed only this much. Okay, right click, select insert code. If you want the constructor, select constructor. Right, now that means when you're creating an object, if you want to pass all the values, it's okay. Have the constructor with all the parameters. Click generate, then the constructor generates for you. Right. And if you want to generate the getters and setters, right now you can say, let's say I want to generate the getters. And if you want to generate both, you can simply say, right click insert code, getters and setters. Getters and setters means it will generate get method and set method both. But now here I don't want to have the all the values. Let's say only the getters I want. Then I'm going to select all the attributes. I'm going to declare the getters and encapsulate. When you click encapsulate, you can see this field become private. Then you will not be able to access through the dot operator. Then it will declare another set of get methods, right? And I want to allow users to change. Then I need to have right click insert code setter. Not for the all, let's say item ID and price, I'm not going to allow to change. And the item name and the quantity. Right, you fill whatever the values required and you generate. And then setters will get declared for the set item name and the set quantity. Right, for this item ID or the price is not changeable now. No one will be able to access it. Right now, this is how you do it quickly. Right now, this is how we achieve the inheritance. Right now, try to execute these methods, try to create an object, get the item ID and get these values and change the item name and change the quantity and print the values. Quickly do it and send it to me via chat, please.
Excuse me, sir.
Yes.
Sir, there's a cooler fan problem in my laptop. So yesterday I figured it out and I sent it to the shop. So I
Okay.
don't have laptop current now.
Okay.
I can't do the task right now. And so
Okay.
can I use mobile
You
to run this in code pen?
right. You will not be able to generate the code using mobile, but you could try out. Then you have to type it, and then you need to find a Java compiler, and then you have to do it. I think rather doing it, it's easier. Once you get the laptop, you try out.
Okay, sir. Thank you.
Right. Then, okay, we have just discussed that how to achieve the right encapsulation. Right, encapsulation. That means hiding all the instance variables by making private and declaring public getter methods and the setter methods is how you achieve the encapsulation. That means now outsiders will only be able to access the read values. They can read the values of these instance variables to these get methods, but they would be able to change only the item name and the quantity. Right now, for an example, if you create an item class object, item item equals new item, right? Then you need to pass the item ID, let's say 101, item name, chair, and price we need to pass the 7,999.99, and the quantity, item ID, item name, price, and the quantity. Let's say 10 quantity. Right now we have the variables, and then you could just print using the name of the variable, name of the item. You could print name is equals to item name. Right now, if you want to display the item name, you could get it by item dot get item name. Right now, get item name. Right now, likewise, if you want to and also when you are using an ID, it's easier if you right click and select format, that will make the indentation as well. Item name, item ID, item price, available quantity. Right now it will display item name. Here get item ID and item price. Get price. Get quantity. Right now, if you want to change the value, let's say we have allowed only to the change the item name, because here we have declared only set methods for item name and item quantity. Others you cannot change. Therefore, if you want to change the item name, then you can say item is the object name dot set item name as a table, let's say. And if you want to change the quantity also, item dot set quantity, item dot set quantity as, let's say, 25. Now this is how you can change the item name and the item quantity. And if you print it now, here you will be able to see the new values. Right, item name is here, and then the quantity also can be printed like this. Right, this is how you could do it. Right now, here it will list the item name chair ID 101, and thereafter we have changed the values item name into table, item quantity into 25. Right. Then here, this is how you could use it. Now, you will not be able to, no one will be able to change the item ID or the item price because there is no set methods declared. Right. If you want to change, then that has to happen only within the class itself, only from the item class, if you want to do it. Right. Then we're going to talk about the inheritance right now. Inheritance right now, let's say I want you to create a class. Okay, quickly create a class called account. Before we go into that, create a class called account, and then account class. Right, then we can have savings and yes, right. Account class have the owner, account ID, and account balance. Owner, account ID, and the balance. Yes. Okay. Quickly create an account class and then create these attributes and then have methods. Right now, yes, declare the getters and setters and the constructor. Okay, quickly do it. I'll give you 2 minutes for you to do that. Okay, quickly do it and send it to me via chat, please. I'll give you maximum 3 minutes time for this. Okay, let's create the class well account. Right, then we have the owner account ID balance. Right. Getters, setters. Done. Right. We have the owner account ID balance. And then here, if you wish, you could say account created. If you want, you can display the account created. New account created. Let's say new account created. And then you can say the account ID. Right, you can display the account ID as well. Right. Now, this is what we are talking now. Okay, we are done with the right. Yes. Okay. Now it's a matter of item class acquired. Right. Now we need to make the driver class. Right. Okay. Now here, let's get into the driver class right now. Here, this is how you could use the right now main method here by creating an account object. You can do it. Right. Now, later on, right now, you just created the account class, right, with the attributes owner, account ID, balance, likewise. And then here, we can have another methods. Right now, I want you to have some methods called, right now, deposit and withdraw. Okay. Okay, quickly add another two methods to the account class, deposit and withdraw. Okay, quickly add it. Add two methods called deposit and withdraw. Right. Deposit and withdraw. Okay, if you have finished, send me the code. What are the two methods quickly?
Sir, can you repeat that question?
I want you to declare two methods called deposit and withdraw. Does it take much time just to write two methods? Send me the answer quickly. Since it takes time, I'm going to write, okay, one of you has sent me the answer. So right now, what you want to do? Right now, let me hide these getters and setters quickly for the time being. Right now, this is the constructor. These are the getters and setters. And then I want to have a method called, let's say, public void deposit. And then you need to get the amount, let's say float amount, or if you get the double amount, you can say this dot balance equals, okay, the same variable right now, you can just call the balance plus equals amount. And you can display deposit successful. 2000, what is the amount? Let's say amount. Right. And the withdrawal also the same. You can say withdraw. And you have to do it inside and if condition if the amount is greater than or equals to the balance, then only you should accommodate this. Balance equals balance minus amount, and then you say withdrawal with success, and else we're gonna say balance. Balance. For insufficient balance, you can say. All right. Right now, these are the two methods we have, deposit and withdraw. Right now, if you create an account class object, you could work with these. Right. Then, okay, let me format it. Right. Okay, done. Now, let's say there are two type of accounts we know already. Now we have savings accounts and we know the current accounts. Right. For the savings accounts, additionally, we're gonna get interest rate apart from these fields, and then you will have interest rate, and apart from that you will have another method called calculate interest. And for the current account, you will not have the no, you will not have the whatever the interest calculation, but then you will have you can right now checkbook issue, request checkbook. Likewise, you can have another method. Right, and then again you can have timed accounts as well, right? Fixed deposit accounts. Right now, duration, you will have another field called duration and the interest. Likewise, you can have. Right now, I'm gonna have just a savings account and the current account. But now, when you're creating the savings account, rather rewriting all the things what we did up to this point, what I can make is I can create another class called savings. I can create another class called savings account. Savings account. Right? Otherwise, class as savings. Right? Java class as savings account. And then I can make it as a subclass of the, I can make this as a subclass of the extends the account class. By using the keyword extends, I can make the subclass of the account class. Now account class become a superclass and I inherit the all the things from the account class. But now here, since I have declared the constructor in the account class, here it asks me to create the constructor as well. Right now, I'm going to have another variable called float interest rate. Float interest rate. Let's say float interest rate. Right. As the attribute I'm going to declare, and I'm going to insert the constructor as well. Right now, here I'm going to declare the constructor generate. Right now, here, apart from this, all other fields are taken from the superclass here. Right now. Let's say we have the balance, and at the end we have the interest rate. Okay, right. Then we have the interest rates. Right now, apart from that, here we need to have another method called void. Right, calculate interest. Cal interest. Right now, when the interest calculation is happening, Right now, how should the interest calculation happens? Balance. We have the balance equals balance multiplied by. Right now, we have to have the balance multiplied by. Right now, we need to say the balance multiplied by. Okay, try to write the balance. Right now, I want to calculate the interest here. Right now, how can we do that? Okay, right now we'll declare the calculate interest in a little while. Quickly create an account class here, savings account, and then make a subclass of the account class. And at the same time, create another class called current account, current, and then that also make a subclass of the account class by using extends keyword account. Right, and then you need to create the constructor for the account class as well. Right now, let's say right now checkbox issued or not. Right now we'll have another method for that. For the time being, no additional fields for the current account class. Right. Okay. Now this is what you have inside the current account class. Right now, create an object from the savings class. Create an object from the savings class, and then try to withdraw and deposit, and create an object from the current account class, and then try to withdraw and deposit. Quickly do it. Create an object from the savings class, and then withdraw and deposit. Right now we'll see by creating object from the savings class and see. Right now, if you want to create a savings account, savings, let's say S1 equals new savings account, we need to pass, okay, let's say Will Smith, okay, John Smith, and the account ID will say 1111, and balance is 10,000, and interest rate is around 10%, right? Okay, and then this would say account created, and then here after this, if you want to right, display the balance account created. Now we have, let's say we need to deposit. You can say S1 dot right now deposit, and let's say another 5,000 if you want to deposit, then it would get deposited, and then if you want to display the new balance balance available, balance available account. Okay, we'll have the account ID. Then you have to call the get account. We have to call the S1 dot get account ID plus balance S1 dot get balance. Right now, likewise, you can get the balance, and then if you want withdraw, you can say S1 dot withdraw. Right, let's say 3,000. You can get the withdrawal, and then after the withdraw, it would say withdraw successful. And then if you want, you can have you can call the calculate interest. Let's say calculate interest, and then the interest will get calculated. Then again, you can display the values. Right now, let's see how can you do it. Right now, when you run this, right now it would display like account created for the account ID 111. Then deposit of deposit of. Right now we have deposit. We have changed it to deposit of. Right, then it should display deposit of 5,000 LKR is success. And then the new balance, it says 15,000, and means like if you try to withdraw 3,000 now. Is it 3,000? Yes, right now why does it say insufficient balance? Right now, let's go and check the code in the account class with this. If the amount is greater than or equals to balance, amount is greater than or equals to balance. Right now, why do you think when I try to withdraw 3,000, it shows me insufficient balance? Why do you think that? Here, this is 3,000, and the 3,000 here is greater than no. Okay, right. The other way I have to use it. If I have more balance compared to the required amount, then I should handle it. Right. Therefore, the operator is amount is less than or equals to balance, right? Then we can try out again. Right. Then we can see if you withdrawal of 3,000 is success. Therefore, after the withdrawal, it says account balance is 12,000. And then we have calculated the interest. Now the interest calculation is available in the savings class. You can see here in the savings class, this is the only thing we have. There are 1,200, 10% of 12,000 is 1,200 is added to the account. And here you can see, and then the new balance also it displays. Right. The same way here, if you create an account class, current account class, if you create a current account class, right? Now, if you create a current account class, right? Let's say we'll have current account C1, and then it has to be new current account, and then let's say T2, and then you don't have to pass the interest amount, and you can do the deposit, and it should display the current account values, and then you should be able to withdraw. It should display, but there should be no method called calculate interest, because there is no such thing called calculate interest, because the current account class can only do deposit and withdraw because it cannot do calculate the interest. Right now, what I wanted to show is here. Now, rather copying the same code which is declared in the account class to the savings class or the current account class. Right now, the current account class, there's no code here. See, just the constructor. But I can create the current account class objects here, and I can work. I can deposit. I can withdraw from the current account class as well. Right now, that is because of right now here for the current account. Now that is because of now here the code inheritance. Like now, rather, alright, by creating a subclass, I can inherit the codes, that means all the methods and the variables declared in the superclass, parent class. Therefore, rather reuse, I can reuse rather reduplicating all the things. Therefore, rather duplicating, I can reuse because of the inheritance. Therefore, inheritance is very important because that allows one class to inherit the features, that means fields and the methods declared in another class. That means Java inheritance is allowing a one class to inherit the features which are the fields and the variables and the methods declared in another class. Therefore, once you use the inheritance, there are two type of class, subclass and the parent class, superclass and the subclass, or child class and the parent class. Likewise, you can say. Right now, in this scenario, the account is a superclass or the parent class. Savings and current accounts are the subclasses or the child classes. Then, child classes inherits all the methods and the variables declared inside the superclass. That means savings account and the current account inherited methods and variables declared in the account class. Right. Therefore, you can see the is a relationship is there. Now you can say savings is an account. Right. Current is an account because savings is a type of account class. Current account is a type of account class. Therefore, account class is the superclass whose features are inherited to the right now inherited is what you call as a superclass. Now, whose features are inherited by subclasses, right? Superclass. Subclass means the class that inherits the other class. The class that inherits from the other class is called as the subclass. So you can call it as a child class or extended class. Right. Now, subclass also can have its own fields as well and its own variables and methods. Now, that's what I did by creating uh, additional interest field called interest rate and additional method called calculate interest. Subclass can have additional fields apart from the inherited ones. Therefore, this allows us to reuse the code which is available in the account class in the savings class as well as the current account class. Right. Right now, this is what you call as the inheritance. That means allowing to reuse or inherit the variables and methods declared in a superclass to child classes. Now that is what you call as the inheritance, right? Inheritance, right? Now this is how you use inheritance, right? The superclass is the class being inherited from. The subclass is the class that inherits from the superclass. Right. Therefore, in order to inherit, you use the keyword extends. Extend is the keyword in order to make a class as a subclass. Right. Now, this is where you could test the protected access. Right now, even here, if it is a variable is declared as a protected, even if it is from the outside the package, right now, even if it is the outside the package, you could access the protected through inheritance. That's what we discussed, right? Inheritance, right? Then, okay, then we have discussed already abstraction, encapsulation, and then the inheritance. Now we have to discuss about the polymorphism. Right now, before I go into the polymorphism, any questions with regards to up to this point? Please ask. Okay, no questions up to now, right? Okay, then we have to talk about the polymorphism. Right now, polymorphism means, right now, the polymorphism, that means polymorphism, the name it says many forms, right? That means right now when we have multiple classes with the inheritance, right now for the same command, we can have like respond differently. That means classes respond differently for the same command. Right now, for an example, right now, let's say we have a class account. I'm gonna have a class called method called but in the account class, I'm gonna declare a method called get info. I'm gonna declare method called get info inside the account class. Public void get info. Right now here this would print now this would print account class. Account time it's account class account account right. Account class. Okay, it just display the account class, right? Now this method right now, if you do not use it right now, okay, now in the here I'm gonna create the account and then I'm just gonna call I'm not gonna use these now. I have created a super class savings account and current account, and here I'm gonna call the get info method, and then for the current account also I'm gonna call the get info method, and also I'm gonna create an account class. Object account class object called A1 equals new account. We need to pass the values. Tom's Jones, Tom Clean. Right, account ID is 3333. Okay, 0000. Okay, 3333. And balance is okay, let's say 25 dollars. Right. Now here also I'm gonna say A1 dot get info. Right now the method get info declared only inside the account class, and then I have not declared in the savings class, or I have not declared it in the current account class. Therefore, since it is declared only in the account class, now in the account class get info method should display account class. Right now if I run this, Right now, A1.getInfo, S1.getInfo, and C1.getInfo all will display the same thing, account class, account class, account class. Right, because of the superclass, I have the method getInfo, but that I have not changed. Therefore, right now, polymorphism means, right, allowing many forms. That means now inheritance allow us to inherit the fields and the methods from the superclass, but the polymorphism allow or users right now for whatever the inherited methods to act differently or the work differently for different commands, different tasks. Now, for an example, now if I don't want to display as an account class, I just want to display right now. If it is a savings class, I want to display it as a savings class, right? Now, in that case, what I have to do is I have to right now in the savings class, I'm gonna write, okay, this is the savings class. Savings class. And for the current account class, also I'm gonna say current account class. This is a current account. Current account class, and for the savings, I'm gonna say savings account class. Likewise. Now if I run this, now you can see here, now I'm calling all the methods at once. I'm calling all the methods at once. Current account class, savings account, and then the I'm calling the current account, savings, and the account class objects, right? And thereafter, I'm calling the getInfo method here, right after creating the objects. I'm calling the getInfo for the A1 object, S1 object, and the C1 object. Right now, if I run this, now it should display A1. That means the same method, getInfo, now act differently. Right now, account class says account class, savings account class says savings account class, current account class says current account class. Now you can see the same method, getInfo. Now, for the same method, same command, invoke the getInfo method. Now act differently. Now each class act differently. That means savings account says savings account, current account says current account, the account class says account class. Right now, this is what you call as the polymorphism. That means you use the same methods to perform different tasks, different behaviors for the same command, for the single command. That means, for an example, if you have if you have different animals and if you have the command called speak, then different animals make different noises. Therefore, they will talk differently. They will communicate differently. Likewise, then, right now, if you say make a noise or make a sound, then dogs will do a different sound and cats will make a different sound. Likewise, it will happen differently. Therefore, that is what you call as the inheritance right now. Sorry, polymorphism. Polymorphism means ability to react differently or the respond differently for the same command. The way of multiple forms. The same method act differently in for the same command is what you call as the polymorphism. Right. Right now, this is what you call as polymorphism. Like when you say speak, right, then you can see the birds, dogs, and the cats act differently. Right now, this is what you call as polymorphism. Like when you have the same command speak, now different animals make different noises. Now that's what you call as the right now. See, this is how you make a different noises when you make the command speak. This is how the different animals make different noises. Now this is what you call as an polymorphism. Right. Right now, that is about object-oriented concepts, right? The basics, 4 pillars of object-oriented concepts we just discussed. Right, then we have to discuss about the method overloading and method overriding. Any questions up to now? Right now, let's quickly go through the content what we have done so far. We discussed about the abstraction. Abstraction is the process of hiding the data but displaying the relevant data, but hiding the unnecessary data from the outsiders. Then class is a general representation of an object. The class specify what are the fields and methods that each object has, but then representation of a class is using an object. Therefore, object represent the class. Therefore, object remains as a representation of the original, but it does not show what are the inside of the each function, how each function works. That doesn't display. That is what you call as abstraction. Right, then therefore if the car is the class, if you create car class and if you create car object, then object represent the car class. That means the class called car serves as an abstract model for the concept of a car. And encapsulation is the mechanism which bind together methods and data it manipulates by keeping both safe from outside interference and misuse. Therefore, that is achieved by making all the fields as private and by providing public accessor methods, by providing public getters and setter methods. Right. Therefore, the object contain instance variables. If they are visible to the outside of the objects, and any code that hold a reference to it can change the object instance variable using the dot operator. Therefore, in order to restrict it, you make all the instance variables as private and declare public getters and setters. Right. Therefore, we discussed about the access modifiers as well. Right. If it is a public, that means visible to all classes. If it is default, visible to the within the package. If it is private, visible only within the class. If it is protected, that is visible the package level class through inheritance. Therefore, here this is a bad example. You can see here the size and weight variables can be accessed using the dot operator and be changed using the dot operator. Therefore, this is allowed but bad behavior. Therefore, in order to make this more maintainable, reliable, what you can do is right now you can make the encapsulation. How can you make it encapsulate? By making all these two instance variables size and weight as private and by declaring public methods for get and set for the size and weight. Right, therefore ways and means are using getters and setters public methods. Right now here for the now you can see we have a class B with the instance variable size, name, color. Make it as private, then outsiders will not be able to access, and create public methods to set and to change and retrieve the values. And that is how you create the encapsulation. Therefore, now class A cannot access class B instance variable data without going through the public methods. Therefore, if the class A wants to access the size value, then it has to go through the get size method. If it wants to change the size, it has to go through the set size method. If you are not declared the set size method, then size would not be able to change from the class. Likewise, you can have the restrictions. Right now, this is what you call as encapsulation. And polymorphism means the capability of an action or method to do different things based on the object that is acting upon. Right now, here you can see there's a class called shape, which has a method called draw. And there are different classes, has become subclasses of the shape class. When you call the method draw, then circle class may draw a circle, and the square class may draw a square, and the triangle class may draw a triangle. Like that's what you call as different to the same method for the same command act differently. And thereafter, we need to talk about method overloading and overriding. Therefore, polymorphism allows different objects to respond to the same message in different ways, then can be achieved through overloading and overriding. And we'll discuss that what is overloading and overriding in a little while. Right. Then we have to discuss about the overloading and overriding in little while, and then we have discussed inheritance as well. Inheritance is the process where one object acquires the properties, that means fields and the methods of another. Right, then we can say like now here you can see here also we use account class is a subclass of the account class is the superclass. Savings and the current are the subclass of the account class. All the attributes and methods are available in the account are inherited to savings, fixed deposits, and the current. And even the fixed deposit is a superclass for the short, medium, and long term. Then a short inherits all the things available for the fixed deposit, and the medium and the long also the same. Right now, that is how what you call as inheritance. Right now, this is what we did. We have created a class called account, and previously with these methods, yes, we have done it. Right, then we have used single inheritance. You can have hierarchical inheritance and multi-level inheritance. You could try out in the future. We will be dealing with those. Right, then right. Okay, we have discussed the superclass construct as well. Right. Okay, then we have the is a relationship as well. I have showed you. That means account is the savings account is a account. The current account is a account. And the savings account has owner, account ID, and the balance. Likewise, we have. Right. Then we have to discuss about the overloading and overriding methods. Right. Before I go into that, again, I'm asking if you have any questions, you can ask now. Do you have any? Right. Okay, I assume you don't have any questions then. Right, then overloading. First, we will discuss about the overloading methods. Right now, in order to discuss the overloading method, right now I'm gonna yes, what is this chat? Must be equals to yes. Right, okay. Right, then let's create method called what? Calculate. Okay, right now let's create what type of class you can create. Okay, let's say calculator. Right now I'm going to create a class called calculator. Right, new Java class called cal. Right now, here right now the class cal has a void method called add. Here, it's gonna say right now it's gonna say cannot add no values to add. Right now, you can see this is the method. Right now, this is a method, and this is a method, right? Declared in the class. Right now, it won't allow you to use the same name, right? Because if you try to use the same name, it will give you an error. But method overloading means reusing the same method name. Method overloading means reusing the same method name. That means use the same method name, but there's a condition by changing the parameters. By changing the parameters, method overloading means using the same method name with different arguments, different parameters. Right now, different parameters. Therefore, it has to change the parameters. Right now, okay, I'm going to declare let's say integer x. Right now, you can see I'm going to say cannot add cannot add just okay. Cannot add just one value. Right now here again, like you can have two parameters, integer x and integer y. Then I'm gonna say total is x plus y. Right now only two parameters. Right, what I'm gonna do is here float x and integer y. See, no issues. See, and if I want, I can have integer x and float y by changing the parameters. Right now, by changing the parameters, now I'm trying this. Right, same method name I'm using by changing the parameters here. Right, or you can have three variables, three parameters. Likewise, you can have. Therefore, if you want to invoke these add methods right now, you could do it here. Now you could do it by invoke the add method by creating. First, you need to create the cal class object equals new cal. Right thereafter, if you just call c dot add, then that means you are executing the method with no parameters. If you just call if you just pass an integer value, that means you are calling this method. If you just pass an two integer values 10 and 20, that means you are invoking the second method. If you pass one float value 10.5 float and 20, that means you are invoking here. You can see float int method. If you pass integer and float, if you pass 10 and 20.5, that means you are invoking this one. Right now, even if you have three integer variables, integer x, y, and z, then you can have x plus y plus z. Right now, you can invoke that by passing three variables as well. Right now, this is what you call as the method overloading. You use the same method name. You use the same method name by changing the number of parameters. By changing the arguments, you use the same method name. That means method overloading means define multiple methods with the same name with different parameters. Defining multiple methods with the same name with different parameters is called as the method overloading. Right now, that is what you call as the method overloading. Right now, based on the arguments, it will execute the relevant method. Now, first one will display no values to add, then it will display cannot add just one value. This would get the two integers has been passed, therefore, this one will get executed. When you pass the three values, then it will execute this one. Right, then if when you pass one value, float value with the integer with float, likewise, then respective methods will get executed. Therefore, remember, method overloading means defining multiple methods with the same name with different parameters. Okay, by changing the parameters. Therefore, when you are doing overloading, it is a must to change the parameters. Okay, quickly try out this. Right? Did you try out that? Okay, then method overloading means right now reusing the same method name with different arguments or different number of arguments or different type of arguments. Therefore, different argument means number of arguments maybe, the type of arguments maybe. Right. And right then, okay. Any questions on this method overloading? Therefore, method overloading is done by changing the number of arguments or changing the type of the arguments. Therefore, by doing this, right now, you could reuse the same method name. Right. Okay, then let's see. By changing the return type, will you be able to achieve the overloading? Right now, for the time being, I'm gonna have this one, and I'm gonna make it as return type as integer. Add, and here I'm gonna say return -1. Right now, I try to do that. Like now, you can say right now by changing the return type of the method is cannot achieve that method overloading, because here it just say right now add is already defined, method add is already defined. Therefore, it is whether it is void or integer, it doesn't matter. It says add method is already defined in the class cal. Add method is already defined in the class cal. If I try to compile this, then I will end up with error saying the method add is already defined. You can say method add is already defined in the class. Therefore, method add is already defined. Therefore, cannot be right now. You can't have the same thing again. Therefore, it's already defined. Right now, the add method is already defined. Therefore, you cannot achieve overloading by changing the return type. Right. Right, then let's say here we have, right now we have add method, and let's say we have another one called, let's say, float x. Right now we have float x, right? Okay. Right, we have float x, and then we have a long x. We have a long variable x as well. Right now I'm gonna say float and here I'm gonna say long. Right. And we have float long, and then let's say integer also we have. Right. Okay. We'll try that later. Okay. Now what I'm gonna do here is now here this is my these are the two values we have. I'm gonna pass just 10. Right. I'm gonna just pass 10. Float long, and then let's say yes, float long and byte. Oh, sure, yes, byte. Okay, sure. Right, I'm gonna pass just 10. What do you think? Which method will get executed now? Which method will get executed? Yes, try out and tell me. Right now, here I'm calling the add method by passing 10. Here I have it takes short parameter, float argument, short argument, or long argument. Which one will get executed?
Short method.
Okay, short. Right, let's run it and see, and then for sure. Right, then let me run this one. Okay, right, run. Now it has gone to long. We have short, we have float, we have long. Now it has taken the long one. Why is it? By any chance, if it is an integer, what do you think? If it is an integer, if there is an integer method, parameter, which one it will execute? Now, if there is an integer, then 10 will be taken as an integer. Therefore, now it has to go into the, okay, now this has to be int. Right now, even if you have integer and long both, no? Let's say we have integer and long both. We have now, right? Okay. Right now, which one will get executed? Now that's the problem here we have. Now we can see here, when you call integer, when you pass an 10, 10 is taken as an integer by default. Therefore, short cannot accept integer. Therefore, short will never get it. Since exact match is there, that will get into an integer. Right now, if you do not have the integer parameters accepted here, then in this case, right now, short cannot accept, and the float, right now here, since it has a compatible type, then it will go to the long. Even the long is not there, right? Then, right, short or float. What do you think?
Sure.
It would be short. Okay,
Short.
let's see. Right, then here now the 10, right now, will it be able to handle? The short will not be able to handle this. Why? Because short variable now, here 10 is taken as integer, no? Therefore now integer will become automatic type conversion will happen to the float. Now this will happen to a float. This will be happen changed to a float. Right now, for an example, if we have integer and short, right, integer and short, and then here if I pass, let's say we have byte variable, byte b equals 10, and if I pass a byte variable here, which method will get executed? Why don't you run it and see? Right now, since we are passing a byte value, then here both short and integer both can accept it, but the nearest one is the short, therefore it will be promoted to the type promotion will happen to the byte short, then it will type promotion will happen to the short. Right now, this is how it's gonna work out. Right, then byte will get to short, then int or long. Right, then let's say here we have passing a byte variable, we have float, and we have double. Right, we have float to double, and also we have long. What do you think? Which one would get? This is float, and this is double. Right. Now, which method will get executed? Now, we are passing a byte. We have float, double, and long. What do you think? Any suggestions? Will it be double? Will it be float? Will it be long? Yes. What do you think? Yes. Okay. Right. Then yes, it will be a what? Float, double, long we have. Then remember this hierarchy. Right now we have, okay, write down if you wish. Right now we have byte, and thereafter we have short. Then we have, what is this? And then we have integer, we have long, and then here we can go for integer, we'll go to float, if not, and then here we have double. Right, now let's have this. Okay, right, first byte to short, short to int to long. And if this long is not there, integer to float, then float to double. But if the float is not there, directly into double. If the long is not there, we'll check whether it works. Long to float and long to double. Right now, let's check the last one. Right now, if it is the long variable, will it can convert it to a double? Right. Now, here I have a long variable, and now here I have a float, and here I have a double, and here I have an integer as well. Right. Now, I have float, double, and integer. Which method will it get executed? Right. Now I'm passing a long variable. Now I'm passing a long variable. Then you can see here, long can be converted to a float. Long get converted to a float. And then if the float is not there, then it goes to double. Then if the float is not there, see, if the float is not there now, if the long variable, now we are passing a long variable, and if it is not there, then it should go into double because integer cannot handle it anyway. Long is greater than the integer. Therefore, now this will go to the double. Right. Now you can say it will go to the double. Right. Now, even if you pass a byte variable, and if you have only, let's say, we have char variable, we have char input, right, my bad. We have char and double. Right now we are passing byte value, right? And we have two parameters, char and double, right? What do you think now? Byte. Byte value we are passing. Obviously, it has to be what? Double. See, byte short, int long. Then we don't have short, we don't have int, we don't have long, and then it directly goes to the promotion, goes to the double variable. Is that clear? Okay, is this hierarchy clear to you? Hello?
Sir,
Yes.
sir, when you declare the variable as long, how can it become?
When you declare the?
When you declare the variable as long,
Okay.
how can it become float without making
Right.
it as
The problem is like now the value we have in the long variable is not like we have 10 or 20 something like that. The a small value, no? Right.
Yes.
Then since we had a small value, then since there is no compatible types, therefore automatic type conversion happens. Then that you call as type promotion happens, and then long get converted to a float.
Okay, sir.
Right. Okay. Now let's see. We have a character value. Okay. We have a character value. Therefore, now remember, according to this chart, you have to remember byte variable can be byte value can be promoted to a short, int, long, float, or double. And then a short variable can be promoted to a int, long, float, or double. Integer can be promoted to a long, float, or double. The long can be promoted to a float or double. Right. And then if it is a char, right now char, right, let's say now I'm passing a char value. Here I have short. Let's say I have a short type of variable, and I have an integer type of variable. I have integer type of variable. Right now I have short and integer. Right, system.out.println. Okay, I have int. Right now, okay, then if I run this, now I am passing a char value here. Then okay, let's say 65. Let's have 65. Then you know what it is. Right now, if I have 65, Right now you can see here a character value, then it goes to a, now this is a char value, right? Char get converted to a, now you can see integer. Therefore, even the for short it doesn't go. Therefore, if it is a character values, right, then here you can have char, right? Then you can have the arrow from here to here. Then char can be int, long, float, double. Right now here, if it is we have a double, short and a long variable, and a double variable. If we have a long and double variable, we'll see what it's gonna be. And right now here you can see the we have double and the long parameters we have. Therefore, now we are passing a character value. Anyway, obviously it won't go for short. We know that. Therefore, since integer is not there, then either it could go for long, it could go for double, it could go for float. Right now, you can see here. Now it's going to the long variable. Right now, since integer is not there, it goes to long. Even the long is not there now. Let's say if we have float, if we have float, if we have float, right now, if you have float now, we don't have int, we don't have long, we have only float, double, short. Obviously, it won't go for short. Then you can see it goes to float. And even the float is not there, it will go for double. Right now, here, let's say, if I have capital A right now, here, character value is capital A. Right now, you can see capital value, character value is capital A. Now, when you pass it, right now, you can see here, capital A. ASCII value is 65, you know that. Then since here short cannot handle it, either it has to go for float or double. Since float is there, it goes for float. Even the float is not there, it is going for integer initially. Integer is not there, long is not there, float is not there. Obviously, it has to go for double now. Therefore, type promotion is from char to double. Right now, you can see double. Okay. Now I am passing a symbol. Okay, a character. Therefore, remember this breakdown, write down somewhere. This is what you call as method overloading and type promotion. Method overloading, type promotion. Right now, here, if you want to write down, byte can be promoted to a short, int, long, float, double. Short could be promoted to int, long, float, double. Int may be promoted to long, float, double. Long may be promoted to float, double. Float may be promoted to double. Char. Char values may be promoted to int, long, float, double. Right. Write down that. Okay, now let me right. Okay, let me trick the compiler. We'll see. Okay, now I'm gonna have okay, short text int y. Okay, long x int y. And int x long y. Right, okay. Right now int x long y. Right now here I'm gonna call the method now. I have to pass two parameters, right? Now you can see two parameters, therefore two arguments has to be passed. I'm gonna pass 10 and 10. Right. Now which one would it be? Right now you will see it is ambiguous. Why? Right now here, according to the method declaration, that is possible, right? Why? Because you can have a different type of arguments. Yes, short int, long int long. No worries. Even you don't have to worry about this at all. Right now, long int long. Like when I pass 10, 10, right now you will see I'm getting an error saying reference to add is ambiguous. Why? Both method add long int and int long matches. Therefore, here this is both are matching. Right now, here, therefore, now compiler cannot understand because both are ambiguous, right? The add method is ambiguous. Reference to add is ambiguous. Therefore, here you will get an error like this. Either if you make it as 10L, that means if you specify, okay, this is a long, if you specify L as a long value, 10L, because otherwise you are passing two integers, no? Therefore, since you don't have two integers, like now this won't happen if you have intex int one. Then it will execute that. Since a long and int, one value has to be promoted to a long, therefore both could be. Therefore, that's why here previously we had the issue when we pass 10 and 10, we have the ambiguous reference error. Right now, this is how you do method overloading. And now we discussed about method overloading, and then we have to discuss method overriding next day. Method overriding. Right, and then when you're coming next day, make sure you read and come about the Java lang dot object. What is the object class in Java? Java lang dot object. Search about Java lang dot object and come when you're coming next day. Thereafter, we're going to talk about Java lang dot object class and the toString method, equals method, and then we're going to override, method override, and thereafter we're going to override the behavior of the toString equals hash code, and then we're going to discuss further. Therefore, make sure you come next week by read and come about Java lang dot object class. What is the lang dot object class? What is special with the lang dot object class? Likewise, just read it and come. Any questions up to now? You can ask now. Other than that, I'm done for today. Any questions you can ask?